Hello there and welcome to this video where we're going to take a look at a problem in mathematics taken from a mathematics admissions test or an MAT. So for those of you that are not particularly familiar with the MAT is an exam or a test that typically you will be asked to sit if you're applying to a university here in the UK to do mathematics or computer science or some certain mathematically related subjects at certain fairly high-ranking universities. You'll be expected, before you get invited for an interview, and whether you get invited for an interview will be partly determined by the result that you get on the MAT test. So you'll sit the MAT before the university invites people for interviews, and based on your results, in part, it will determine whether you get invited for an interview. There's other factors that will be taken into consideration as to whether you get invited for an interview. It's not all down to the MAT, but it will be taken into consideration, your performance on the MAT. So what should you expect on the MAT? Well, you should expect so typically you will be familiar with the kinds of questions, the style of questions from your A-level maths or further maths textbooks and the kind of problems that you encounter on past papers. The style of problem and question that you get asked on an MAT is going to be a little bit different. Okay, it's going to be a bit more challenging. You're going to have a bit more thorough and in-depth understanding of the techniques that you learn about on your A-level maths course. You don't need to have done further maths to do the MAT or to be successful in the MAT, although naturally it may put you at a little bit of a disadvantage if you haven't done further maths. And it's not because the techniques that you're expected to be aware of and expected to apply and use on the MAT involve techniques that you would typically only encounter on the further maths part of the A-level course. It's just that typically the further maths students will have a bit more practice, a bit more experience at dealing with certain mathematical problems and looking at things in certain ways and using certain techniques in certain ways that might give them a bit of an edge when it comes to doing the MAT. Nevertheless, if you're just doing the normal A-level maths course, if you have a good, thorough understanding of the theory and the techniques that you've been learning about, and you can use those techniques in creative ways, in inventive ways, then there's no reason why you can't be successful on the MAT. You might just have to do a little bit more work, but there's no reason why you should be put off from doing it or discouraged in any way. You can go on to do mathematics at university and be very successful. Okay, so the problem that I've chosen for this video is from a past paper for the MAT. So it's the 2008 MAT past paper, and it's question B. So I'll leave a link in the description to this video where you can download this past paper. So actually, I will be more or less writing it up on the board anyway, but you can download it anyway, and you can get a feel for what kind of things show up on the MAT, and you can get a bit of practice and things like that. I have provided, just so that you know, I have provided private tuition, one-to-one tuition in the past for people doing preparing for the MAT. I've helped people prepare for their university applications for mathematics and mathematically related subjects, and for STEP and for further maths A-level and the normal maths A-level. If you would like to find out more about how I can help you develop your problem-solving skills in mathematics and prepare for MAT, STEP, and your maths and further maths A-level exams, please feel free to get in touch. I'd love to have a discussion with you about your needs, your requirements, and how I can help you. And I'd love to help you secure your place at whichever university it is that you're wanting to go to, and for you to reach your true potential. So please feel free to get in touch. I'd love to hear from you. Okay, so let's get on with the problem. So this problem involves, it's a multiple choice problem. So in the MAT, the first few problems are multiple choice, and that doesn't mean that they're easy, by the way. And it doesn't mean that you should guess your answers to them. Not at all, okay? You still need to show some substantial working. It's not all about just getting the right answer. It's about how you get there, okay? I'll say more about that in a minute, but the later problems on the MAT are a bit more structured. There's more parts to them. They're not multiple choice, and they're really challenging, really testing how well you understand the theory, the techniques that you've learned on your maths course. Okay, so typically the kind of stuff that's going to be covered is the techniques that you encounter in your first year of A-level maths, and maybe the first bit of the first term of the second year might show up as well on the MAT. So it's important on the MAT that you really show how you're arriving at your solutions to the problems. If you just, so if it's multiple choice and you just guess all the answers, you just circle all what you think are the right answers and you don't show any working, this won't wash, okay? You've got to show how you're arriving at your solutions. Even if your answer, the answer that you give is wrong, if you can actually show that you had a good reason for giving that answer, that will count for more than if you circle the right answer without any working, okay? So question B, it's one of the multiple choice ones. So this video is maybe going to be a little bit shorter than some of the, well, it's going to be probably considerably shorter than some of the others that I've done. And what we're given is a series of expressions, logarithmic expressions. So log to the base 10 of pi, log to the base 10 of pi squared square root. What's the next one? I forget. 1 over log to the base 10 of pi cubed. And finally, 1 over log to the base 10 of square root of pi. Okay. So what we're required to do is to find which is the smallest of these four values. Okay. Now, bearing in mind that we do not have a calculator in the MAT, unless anything has changed very recently that I'm not aware of. You don't really have a calculator in the MAT. Even if you do have a calculator, it's not going to be of any use to you. As mathematicians, we don't rely on calculators to tell us our answers, really. We need to be showing how we're using solid mathematical techniques to determine the solution to this problem. So what people sometimes get confused about when, for example, with this problem, when it says, which is the smallest of these values, the fact of the matter is we don't actually care. Nobody cares which of these values is the smallest, especially mathematicians, right? What a mathematician is really interested in is how do you establish which is the smallest of these values, okay? So that's why it's important for you to be really using mathematical techniques to show how you would establish which is the smallest of these values, because we don't really care which is the smallest of these values. Okay, so naturally, because this involves logarithms, you're going to have to be pretty familiar with algebraic manipulation when it comes to logarithmic expressions, which means that you're going to need to know your laws of logarithms. Now, there's all sorts of things that crazy things that people do when it comes to logarithms. So, for example, and I'm sure that if you're watching this, if you're preparing for the MAT, you don't make these mistakes, right? So I'll suppress the base. We don't need to worry about the base. So the first big mistake that people make with logarithms is that they'll treat this like a number. Okay, so bearing in mind, if you've got something like 4 times x plus y, this would be 4x plus 4y, right? Multiply 4 by x, you multiply y by 4 by y. So they'll come to the conclusion that this is equal to log x plus log y. Okay, which of course it's not. There is no rule that says, in general, log x plus y is equal to log x plus log y. Log is not a number, it's a function. So because it's a function, it's not a number, it doesn't necessarily behave like a number. Okay? There are certain types of functions, linear functions, for example, that do, in a way, behave like numbers in certain respects, but log is not a linear function. Okay? So, this is a no-no. Another one is that, for example, we might have something like log x plus log y, which, if you know your laws of logarithms, you know that this is equal to log of x times y. Now, people, unfortunately, will try to remember this in some wishy-washy, wavy-handy kind of way as, well, when you add logarithms together, you multiply them together. And they'll come to the conclusion, therefore, that when you add these two logarithms together, that this must be equal to log x times log y. Because they've not been precise enough. When they've committed this to memory or whatever, they've not really thought about it carefully enough. They've not made decent enough observations. And rather than noticing that when you add two logarithms together, you multiply the arguments, they'll just say, oh, when you add them together, you multiply them. Just some wishy-washy, cack-handed way of remembering this law of logarithms. And it'll lead them into all sorts of difficulties. But what do I anticipate here is going to be an issue? Well, one of the things is this here. Right, so we've got square root of log to the base 10 of pi squared. The natural reaction for people, typically people who don't really have a well-developed understanding of mathematical notation and certain mathematical concepts, may still be aware that a square root will cancel a square. But obviously this depends on how the square root and the square relate to each other. Okay, so, but nevertheless, they will look at this and they'll say, square root, square, cancel. This is equal to log to the base 10 of pi, which, of course, it's not. Because there's something kind of intervening here. We've got pi squared, but we've got this log to the base 10, which is between it and the square root, so to speak. Okay, so we don't get the cancelling out. So, be really careful about how you use your laws of logarithms. By the way, this video is not meant to be kind of a model solution to this problem. Okay, the particular problem that I've chosen and the particular solution to this problem is kind of secondary consideration. What I'm more interested in is how the solution to this problem or any other problem develops. Okay, so what I do in this video and other ones like it that I make is to present my solution to that particular problem, and it's my solution. It's not a mark scheme solution. It's the one that I've come up with, that I've had to think about, and I try to describe and articulate the process, the means by which I arrived at my solution, and that involves me, in some cases, talking about certain ideas that didn't necessarily work. So I might have had an idea about how I was going to solve this problem. I tried it out and it just didn't work. But that's part of the problem-solving process. And I try to get that through in these videos. Okay? I leave all of that kind of stuff in. So if you don't like that, watch another video. But for me, that's part of the problem-solving process, accepting that happens. What I aim to do with these videos is to help you find a way to develop your problem-solving skills by trying to kind of introduce you to certain ideas that maybe you haven't encountered before. So I might do something in my solution, you might think, I didn't know you could do that, or I've never seen that technique used in that particular way. That's interesting. You might stimulate some fresh ideas in your mind that will help you develop your problem-solving skills. Okay, and that's all I'm aiming to do in these videos. So if they're a bit rambly, that's kind of intentional. Okay. I might advise that you take notes and that you maybe re-watch certain parts of the video so that you get all of the information. If you do need any clarification with anything, please leave a comment in the comments section. because I don't expect that I will explain everything perfectly as I go through this video, because it's not scripted. I'm going to do very little in the way of editing with this video. It's however things come out, that's how they come out, that's how they end up on the camera in the video, and that's how you're going to end up watching them. Okay, so one thing that I noticed with this, this was one of the first things that I wrote down, and it turned out actually to be quite useful. It's important when you're trying to solve a problem to acknowledge your ideas. Sometimes they work out, sometimes they don't, but you never know. Sometimes you think of something and you think, I'm not sure that that's actually going to be useful. It turns out to further down the line be exactly what you need. One thing that I noticed is that because pi is less than 10, but also pi is greater than 1, that means that log to the base 10 of pi, it's going to be greater than 0, but it's also going to be less than 1. Okay, in other words, log to the base 10 of pi is somewhere between, not including 0 and 1. Okay, this is potentially going to be quite useful to us. How? Well, let's find out. So, how am I going to establish which of these values is the smallest value? If I don't have a calculator, it's going to be very difficult for me to even start trying to manually calculate any of these values, and that's kind of why these values, I guess, have been chosen. So you can't even do that. You've got to find a much more inventive and creative way of establishing which is going to be the smallest. Okay, so one way that you can do that is to consider differences. So for example, if I've got two numbers, A and B, if I know that A minus B is less than 0, that means that A is smaller than B. If I know that A minus B is greater than 0, that tells me that A is greater than B. Okay, so this might be an idea that you use. I'm not saying it's the only idea, but this was the idea that I pursued, because this is one way that you can determine which of two numbers is the greatest or the smallest, as the case may be. You could also go for potentially ratios. So A divided by B. If this is greater than 1, then that means that A is greater than B. If A over B is less than 1, that means that A is less than B. So there's different possibilities, and you've got to decide which of these possibilities you're going to go with. But the important thing is that you make a decision. Okay, that you're decisive. You say, I'm going to do this, and you follow that course of action. It might turn out to be wrong. It might end up taking you in a wrong direction. There's nothing you can do about that necessarily. That's going to happen when it comes to problem solving. There's no guarantees. You've just got to try beforehand, before you've got an exam or something like that. You've got to try to make sure that you're as prepared as you can be, as well you know. Okay, so let's have a look at, say, which two did I take first? So logged. Okay, maybe let's have a look at these two. So log to the base 10 of pi and log to the base 10 of pi squared square root. Okay, well, because I know that both of these are positive, this is going to be between 0 and 1, it's going to be between 0. Okay, so if x and y are both positive, if x is greater than y, so x is greater than y if and only if and only if x squared is greater than y squared. Okay, so that might be something that I could take into consideration here in order to get rid of the square root. So that would tell me that if I want to compare these two, instead of comparing these two quantities, I could potentially compare log 10 pi squared and log 10 pi squared. Okay, so this is like my x and this is my y maybe. So then this is my x squared and this is my y squared. So I'm not suggesting, by the way, that x is greater than y. I'm just that's just illustrative. So then I can compute. I can consider the expression log to the base 10 of pi all squared minus log to the base 10 of pi squared, which, by the way, using lots of logarithms, this is going to be twice log to the base 10 of pi. Okay, so this is equal to log to the base 10 of pi times log to the base 10 of pi minus 2. Okay, so just taking log to the base 10 of pi out as a common factor. Well, that's going to be greater than 0. Okay. But this, log to the base 10 of pi, remember, is less than 1. So this is going to be less than 0. So something positive times something negative is going to be something negative. What does that tell me? Log to the base 10 of pi is going to be less than square root of log to the base 10 of pi squared. Okay, so this can't be the smallest value of these four. Okay, how did I know to do this? I didn't. Okay, that's the point here. When you're solving a problem, you don't necessarily know from the outset exactly what you're going to do. You've just got to kind of follow your nose, follow your instincts, trust your gut, and just be prepared to do something which may end up being wrong. Okay, so we've established that. That's so far so good. So let's have a look now at comparing maybe log to the base 10 of pi with 1 over log to the base 10 of square root of pi, which, by the way, is equal to 1 over a half log to the base 10 of pi, which in turn is equal to twice 2 over log to the base 10 of pi. So this is just laws of indices to get from here to here, and that's just, well, multiply numerator and denominator by 2. Okay, there's no laws of indices involved, laws of logarithms, sorry, involved there. That's just multiply numerator and denominator by 2. Okay, so really what I want to be comparing in that case is this and this. So let's have a look. What do I get? Log to the base 10 of pi minus twice 2 over log to the base 10 of pi. This is equal to log to the base 10 of pi squared minus 2 over log to the base 10 of pi. Well, I know that log to the base 10 of pi is greater than 0. And I know that log to the base 10 of pi is also less than 1. So log to the base 10 of pi squared is also less than 1, and therefore this numerator is going to be less than 0. Less than 0 divided by greater than 0 is going to be, therefore, overall less than 0. What does that tell me then? That log to the base 10 of pi is going to be less than 1 over log to the base 10 of square root of pi. So that's not the greatest value. It's the smallest value. So we're just kind of knocking out as many as we can, really. Again, how did I know to do this? I didn't. I just kind of messed around with things until something worked. Okay, so then we move on to the final one, which is comparing these two, and it's this a similar kind of idea that I'm gonna use, I guess. Although, okay, I've actually just thought of a different way that I could have done this to the way that I actually did it. So I'll do the way that I did do it, and I'll show the other way that I'm thinking of. So we want to compare log to the base 10 of pi and 1 over log to the base 10 of pi cubed, which is, of course, equal to 1 over log to the base 10 of pi all cubed. Right, so subtract one from the other. Log to the base 10 of pi cubed. And I can write this as 1 over log to the base 10 of pi cubed times log to the base 10 of pi to the power of 4 minus 1. Okay, so effectively taking 1 over log to the base 10 of pi cubed out as a common factor. Why would I do that? Because it works. Because then this is greater than 0. And this here, because log to the base 10 of pi is less than 1, log to the base 10 of pi to the power of 4 is going to be less than 1. So therefore, something less than 1 minus 1 is going to be less than 0. Something greater than 0 times something less than 0 is going to be something less than 0. What does that tell me? That this is less than 1 over log to the base 10 of pi all cubed. So therefore, this is not the smallest value. Well, by process of elimination, we get that log to the base 10 of pi is the least value of these four expressions. Now, another way that I actually just thought of doing this, and I may as well include it here because there's no harm in doing so, using the idea of a over b less than 1 implies a is less than b, and so on and so forth. What I can do is I can consider the ratio log to the base 10 of pi divided by 1 over log to the base 10 of pi cubed. So this is a separate calculation now, which is log to the base 10 of pi over 1 over log to the base 10 of pi cubed, which of course is equal to log to the base 10 of pi to the power of 4. But since log to the base 10 of pi is less than 1, log to the base 10 of pi to the power of 4 is going to be less than 1, and therefore log to the base 10 of pi is going to be less than 1 over log to the base 10 of pi all cubed, which establishes exactly the same result. I arrive at the same conclusion. It's just that actually I prefer that way. I didn't think about that as I was going through this problem the first time. I didn't think about that, but just I thought about it just now. So there's different ways that you can go about it, and it's really digging deep into your knowledge, your understanding, and really showing that you have ideas. The important thing on the MAT is showing that you have good ideas, even if you don't fully follow through, even if the idea doesn't properly do the job. Articulate your ideas. Okay, so that brings us to the end of this problem, and it brings us to the end of this video. So thanks for watching, guys.